We're going to do another demonstration of synchronizing two AC three-phase generators. We have these two three-phase generators hooked up on belt drives to a pair of AC induction motors. They're being powered by some VFDs, so we have the ability to control the driving frequency of the VFDs, to control how fast or slow they're trying to spin, and then we can take these two generators and electrically link them together through our circuit breaker network. Presently, both generators' breakers are closed, and so they're on the same grid, so to speak, and they are now electrically coupled together. Our stroboscope, which is putting out a flashing light signal, is showing this coupling, and you can see that when you align the two tape marks in your vision, you can see that these two tape marks are showing these two generator shafts to be in sync with each other. Going at the same speed, they're not drifting at all, because again, they are electrically coupled with each other. What I'm going to do now is purposely slow down the prime mover on the foreground generator. I'll slow down the frequency going to this motor so it tries to spin slower. Since these two generators are still electrically coupled together, electrically linked together, they will still spin at the same speed, but this one won't be trying to spin as hard as before. In fact, it'll be trying to slow down, and as a result, this will begin to act as a motor, and the background generator will act as a true generator. So watch as I slow the frequency down on the motor here from 60 Hertz down to about 59. So 60, 59.8, 59.6, 59.5, 59.3, 59.4, let's try that again, 59.2. So what's happened now is I've slowed this down, or I've tried to slow it down, I should say, and as a result, this generator is not being mechanically spun as hard as it was before. It's actually now receiving power from the other generator as a motor to try to keep up the speed. And as a result, you can see a slight splaying of the angles in the tapes. This one should look like it's further clockwise or further behind rotation of the background generator. Now I'm going to speed up the prime mover on this, and when I do so, you'll see the tapes come closer into alignment with each other. So here we go, 59.2, 59.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 60 Hertz. So now with 60 Hertz going to the driving motor, it's now trying to spin exactly as fast as the other driving motor, and what you see here is better alignment of those two pieces of tape. Now I'm going to go the other way. I'll take the foreground generator's driver and turn its speed up to about 61 Hertz. And what we should see is another splaying of the angles here, where the foreground generator is actually driving ahead of the background generator, acting as the true generator in the system, with the background acting as a motor. So I'm going to turn this frequency up, 60 Hertz, 61, 60.2, 60.3, 60.4, 60.5, 60.6, 60.8, 60.9. So now we're at 60.9 Hertz, so we're trying to mechanically drive this generator faster than the one in the background. And as a consequence, we see a slight splaying of the angles between that tape and that one, with this one slightly ahead, slightly further counterclockwise. So again, this generator is trying to push harder, but it can't go faster because it's electrically linked to the background generator here, and they will keep each other in sync, even though there is a slight displacement between them. This is analogous to having a mechanical coupling, a flexible mechanical coupling between these two shafts. And when one device tries to spin faster, it will flex and stress that coupling and allow it to splay an angle slightly, depending on which way the torque is going, whether the foreground generator is applying torque to the system or trying to take torque away from the system. I'm now going to slow down the driver for the foreground generator back to 60 Hertz. They should now fall perfectly in sync. 60.5, 0.4, 0.3, 60.0. And now we should see those two pieces of tape being in much closer alignment than before, showing that these two generators are no longer laboring against each other, but they're truly and equitably in sync.